Hello dear students, how are you? Welcome again in my statistical channel. This is Jurand Skrzypek and this is my statistics course. Today I will show you the additional lesson which is entitled Statistical Methods in Excel Spreadsheet. Today we are going to learn how to utilize the wisdom, the skills that you have gained during the statistics course. In other words, I will show you how to compute the basic statistical measures in Excel spreadsheet. Let's start. Alright, at the beginning, few words about the entire statistical process that I have utilized here. On this graph, you can see the next steps in the entire statistical process. The first step is to formulate the research problem. The research problem here comes from my private investigation. I must stress that at the beginning of the previous winter semester, I asked my students about their estimated distance between their place of residence and Krakow. And this statistical variable, estimated distance between places of residence and Krakow, is expressed in kilometers as an integer. This is my research problem. After formulating the research problem, I defined the population. The population in my research are the students of the business and finance management. This is my population. The students that have participated in my statistics course. The third step, the most important here in this spreadsheet, is to collect the appropriate data. So I asked my students in the Pega system about the estimated distance between their places of residence and Krakow, and the results were following. As you can see, I have 50 responses to my research. My research has been ended in November. So, in other words, I have 50 observations. My population size, n, small n, is equal to 50. And here in this column, I have disordered statistical material. It's very easy to obtain the statistical series based on statistical material. So now we are going to transform the statistical material into a statistical series. I can use here a filter, and I will open the menu and I will organize my statistical material from the smallest to the largest value. One click, and now I have here individual statistical series. Yes, ordered in non-descending way. Ta-da! Okay, let's move on to the next spreadsheet. But before that, I must explain that a few moments ago you didn't see the filters context menu. Sorry about that, but actually we won't use it anymore, so it doesn't matter in the future. Let's focus on our research. On the left side, you can see our real data about the distance between the places of residence of students and Krakow. Our data has the form of the individual series. This form has some advantages. Like here, we know all the details. We know every value of our statistical variable. Yeah, x1 is 0, x2 is 0. For example, x20 is 295, x50 is 11,521. We know all the details about our statistical variable. But really, this form of the presentation of the data is not readable, yeah? Let's imagine the situation after copying this table to a Word or to PowerPoint presentation. It will not look very clear and concise. Yeah, we need more effective form. We need a clearer form that shows, first of all, the structure of a given population due to the values of our variable. This form is called the interval series. So the next step in organizing our data, our individual series, is to transform the individual series into the interval series. As you remember from my previous lessons, the interval series can be characterized by two parameters. The number of the classes, represented by K letter, and the range of the classes, represented by C letter. Okay, but the first question is how to choose K and C parameters, appropriate C and K parameters. We have basically two approaches. The first approach is individual one, and the second one is more formal. The individual approach depends on our imagination. Yeah. For example, I can shape our interval series in the form of maybe first class will start with 0 kilometers and it ends with 100 kilometers. The next class will be from 101 up to 200 kilometers, and so on. It depends on our imagination, our ideas about how the table should look like. This is the first approach, but the second approach is more formal. We can use some formulas in order to indicate K and C parameters. The formulas are following: K equal to 1 plus 3.3 multiplied by logarithm of the population size, and C the difference between maximum and minimum value divided by the number of the classes. Dear students, please don't ask me why K is equal to blah 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 and C is equal to blah blah blah. I'm sure that those formulas are supported by a lot of research, done by serious statisticians. So If you want to check it out, please run your Google search engines. Alright, so let's start with computing the number of the classes. In our example, we have, first we type equality sign, and after that we press 1 plus 3.3 multiply sign, yeah, and then we have logarithm. Yes, here we have appropriate function from Excel, logarithm. Logarithm of the population size. Population size is, of course, 50. Yeah, we close the bracket, we press enter. So the number of the classes should be approximately equal to 6 and 6.6. It means that we should have 7 classes. Yes, because we we must have here an integer number of the classes, of course. Yeah, 6.6, the closest number to 6.6 is 7. Okay, so here we will have 7 classes. Now we can indicate the range of every class. Statisticians propose this kind of formula. Equality sign, we open the bracket because here we are dealing with the nominator, maximum value minus minimum value. We close the bracket, divided by the number of the classes. Yes, and here we have a typical range of every class, 1645. Okay. Okay. Let's start with the formal approach. Let's create the table of the interval series based on those formulas for K and for C. At the beginning, few remarks. Excel allows us to create interval series with, attention, with at least one-sided closed intervals. This is the feature of the appropriate Excel function. It means that we have the intervals in the following style. For example, from 0 up to 100, with 100 and with 0. Remember, at least one-sided closed intervals. The next interval starts with the same number, 100. Yes, the number is repeated here. 100 is the upper bound of the first class, and 100 is the lower bound of the second class. The same number, but we exclude 100 in the second class, of course. Up to 200 with 200, because every interval is at least one-sided closed. And so on. 200 without 200 up to 300 with 300. As you remember, in my previous videos, I used simple disjoint intervals, like here from 0 up to 100, and I start the next class with the next integer, yes, plus the next integer that comes after 100. It is 101, yeah. So I have here separated intervals. It's also correct approach, but I want to take advantage of all the Excel possibilities. Okay, let's back to our investigation. The good habit, how to start, how to establish the lower bound of the first class, is to take the minimum value. Yeah, equality sign, and B8 represents the minimum value, which is 0. As you know, the scope of every class is 1646 almost. So I have to sum 0 and my range of the class. Yeah, okay, a range of the class is the same everywhere, so I press F4 button, yes, in order to fix our cell I12. Okay, I press enter and I can move on to the next class. The next class starts with the same number as in the upper bound of the first class. Yeah, like here in this example. But we know that here in the second class 1646 almost is excluded from our considerations. Okay, and here we can click on the right bottom edge of the cell. Yes, click and hold and drag the cursor down. Yeah, and now we have the upper bound of the second class. Yeah, I can drag the formulas to the bottom of the table. Yes, so I mark the cells from F17 to H17. Yes, I move the cursor to the right bottom edge of the cell, click, hold, and drag the formulas to the bottom of the table. And as you can see, what we have here we have automatically received the maximum value, so it means that everything is okay. Yeah, I can delete those examples. Okay, and here on the basis on real data, I created the table of the interval series with 7 classes. All right, so now I am able to indicate the rest of the categories that are associated with the interval series, which are NI, which is the frequency, Fi, the relative frequency, NSI, the cumulative frequency, FSI, the cumulative relative frequency, and xi with a dot at the top of x, which represents the middle of the class. Okay, so the first step in our interval series construction will be the computation of the frequencies, the computation of the values in the first column, entitled Ni. It's very simple. What should we do? Please mark all the cells in Ni column. Okay, done. Please press equality sign button. Alright. And now we can start type frequency. We have frequency. Calculates how often values occur within a range of values and then returns a vertical array of numbers having one more element than Bin's array. Yeah, it's very wise. So let's utilize this formula, frequency. Double click, and now I am obligated to mark the data array. The data array is here, the entire data from the individual series. Yes, click on the first observation, hold left mouse button and drag cursor to the bottom of the data. Yeah, data array is okay, so I press semicolon, and after that I mark upper bounds in our interval series. Yeah, okay, everything is okay, and now at once, simultaneously, I press Ctrl, Shift and Enter. Yeah, very nice. Yeah, I have received all frequencies. Let's check it out. I sum up this column. Yes, I press Auto Sum. Enter 50. Everything is okay. I have 50 observations. Let's check it out. From 0 up to 1647, I should have 26 observations. Let's check it out. Yes, here 1060, 1726 is higher than the upper bound of the first class, so everything is okay. Everything is okay. Congratulations. Okay, so now we can move on to the next column, relative frequencies. Now we can see the structure. Now we are able to see the structure of the population, business and finance management students, through a prism of considered statistical variable, which is the distance between the places of residence of the students and Krakow. It's very easy and quick in the computation. We can start with, of course, equality sign. Yeah, and as you remember, this Fi is a ratio between Ni and the population size everywhere. So I have to fix, pressing F4 button, I have to fix the value of the population size by $2 before I and 23. Here we have $2. Okay, I can press now enter. Here we have 52%. This is the information that 52% of the population, 52% of the population is characterized by the distance between the place of residence and Krakow not higher than 1,646 kilometers. Yeah, and once again I can click, hold and drag this formula to the bottom of my table, and in order to check it out, if I've done it correctly, yeah, the sum of this column is exactly 1, so it is consistent with the theory. Okay. And now is the right time for the cumulative categories. First cumulative category is frequency, cumulative frequency. Cumulative frequency of the first class is frequency of the first class. Yeah, Ni from the first class, it means N1. N1 is equal to NS1 always. Yeah, both categories are always equal to each other. Okay, the second cumulative frequency is the previous cumulative frequency plus the currently frequency. Once again, the second cumulative frequency is equal to the previous cumulative frequency plus the second frequency. Okay, and I can select this cell, click and hold the left mouse button and drag the formulas to the end of the page, to the end of the table, of course. Yeah, and the cumulative the last cumulative frequency is equal to the population size, so everything is okay. The same thing with the relative cumulative frequency. The first cumulative relative frequency is equal to the first frequency, and then the second cumulative frequency is equal to the previous cumulative frequency plus a current relative frequency. Yeah, and the same thing. Everything is okay because, as you can see, 100% of the population is characterized by the variable value not higher than 11,521 kilometers. Yeah, it's very important information for us. Okay, and the last one category is the middle of the class. Yes, as you remember, this is the ratio between a range of the class actually and 2, the value of 2. In other words, this is the arithmetic mean. Yeah, arithmetic mean of the lower and the upper bound of a particular class. So we can start with equality sign. We open the bracket because we are working with denominator, with a nominator, sorry, lower bound of the class plus upper bound of the class. We close the bracket and divide the sum by 2. This is the arithmetic mean between both values, or in other words, the value that lies exactly in the middle between lower and upper bound of each of the class. Yeah, here we can change the number of the places after a dot. Yeah, 3 places after a dot is a default accuracy. And here we can continue our computations by clicking, holding and dragging the mouse button, and our table is ready. Our table is ready.
I am back. I am back with a new software, Microsoft Stream, and as you can hear, the quality of the sound is much better. And finally, you will see the context menu and new opened windows. Very nice. Okay, the next step in our work with the data will be the graphical presentation of the data. I know some of you prefer a graphical form, so I have prepared some tips and tricks how to do a pie chart on the basis on the interval series. First of all, we need the labels in our pie chart. Labels. The labels are actually the intervals, because the intervals characterize the classes in our population. So, as you can see, the intervals are placed in 1, 2, 3 columns, so we should combine 3 columns together into one column. We utilize the function of concat, which concatenates a list of range of text strings. Yeah, double click on that function. And okay, let's mark the first text. But as you can see, we have some decimals in our intervals. We can avoid the problem of decimals because we don't need the extension of those decimals. Yes, the integers are enough. So we can also utilize here the function of round. Yeah, rounds a number to a specified number of digits. Yeah, double click of round, number 0, number of digits 0, close the bracket, semicolon. Yeah, we can utilize this symbol in the middle, and next semicolon, round, of course, round, and here we will round 1645.857 blah 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 into, as you can see, oh sorry, number of digits 0. We have rounded this number into 1646. Everything is okay, yeah? So move the cursor to the right button of the cell, and as earlier, drag to the bottom of the table. And now we have our labels. Okay. And the next step is to insert a pie chart. Here we have some charts. Maybe we can insert here a 3-dimension pie. Okay, here we have 3-dimension pie, but now we don't see anything because now we have to select the data. Okay, chart data range. Our pie will be constructed on the basis on a relative frequencies. Yes, because it shows the structure of the population in point of view of the distance. Mark all values from the column of relative frequencies. Okay, we have the series 1. We can edit this series. Yes, series name xi expressed in kilometers, for example. Yeah, here we have our chart and edit horizontal axis labels. And now we can make a use of those labels that we have computed earlier. And brilliant. Yes, here we have our chart. We can close this column. And now we have some samples, yes, so patterns, how we can present our data. And here we have very nice graph which represent the structure of the population, the group of the students of business and finance management, and through a prism of the distance between their places of residence and Krakow. And as you can see in this pie chart, 52% of the students are characterized by the distance between place of residence and Krakow not higher than 1,646 kilometers. Yeah, so I think this is the area of Europe. Yes, and the second information that we have obtained from that information is that 48% of students are characterized by the distance higher than 1,646 kilometers. Okay, it's all for today, unfortunately. Thanks for watching the movie. Soon I will try to prepare another lesson about measures of position and dispersion in Excel spreadsheet. It's all for today. Take care. See you soon. Bye.